Stephen Barlett. I'm a junior CS major with a minor in ECE. Our final project for embedded systems is a memory-based pattern game. The Freedom Board will generate a random pattern and display it on this LED matrix. And then the player's responsibility is to input the same pattern on these buttons. We've implemented a time limit so that the player can't take too long to implement the pattern. And also, as the game goes on, the patterns will get longer each round. We display the current score on this scoreboard on the right-hand side and the max score on the left-hand side. It's gone.
Hi, my name is Stanley Liu, and I'm currently a junior at the College of Engineering studying electrical and computer engineering. And this is our final project, and I'm going to do a demo for you. First, we press this button on the board. This is the button used to start the game or restart the game. And we input the pattern. You can see the current score is updating. And if you do an incorrect input, it will display a frowny face, and it means you lost. And this time, if I press this button again, my current score will get updated to the best score, and the game will start from round 1 again. And this time, if I do not do anything for the input, just wait a few seconds, the game will automatically time out, and it failed. We use extra hardwares to implement this game. The first is this 8x8 LED matrix that we divided it to 4 quarters, and each quarter is corresponding to one of the buttons on the input board that displays the pattern and input the pattern. And we display the score on the 4-digit LED display. The right-hand side is the current score, and the left-hand side 2 digits are the highest score. We also use a pit timer on the board that is externally built and use it to time out the gamer's input. As a user input, we use 4 buttons on the breadboard to use as input. They are connected to the GPIO pins on the board, and each of them are working like a switch that controls the on and off of the circuit, so the board will know that if a button is pressed or not. We use a polling loop to poll all 4 buttons and to see if the input pattern matches with the pattern that is generated randomly.
The most difficult part of this project was interfacing with our external components, this screen and the scoreboard. We used the MAX 7219 8x8 LED array and the TM1637 4-digit display. The MAX LED array uses a SPI communication protocol. We implemented that using the SPI ports on our board here. It was challenging to debug that when we had issues because when we weren't sending the right signals, we got no feedback at all on this screen. So it took a long time and a lot of staring at the data sheet to figure out how to use it properly, but we got there. The 4-digit display here doesn't use SPI, but it does use a different serial communication protocol. It wasn't immediately obvious what protocol that was, but we seem to think it's based on I2C. There wasn't an existing driver for the Freedom Board for that, so we had to write that ourselves, along with just the general libraries for both of these displays. That was the most challenging part, but another issue we had was randomization on the Freedom Board. We ended up using analog input from an unused pin and using that to seed the C random library to get unpredictable patterns. That seemed like a very complex solution for something that seems so simple, but that's what we settled on.
Thank you for watching this video. If you like our project, please remember to subscribe, like, share, or leave any comments below.